This is Mr. Gillum, and today we're going to start learning about absolute value and ordering numbers. It's on page 118 of your instruction book. Let's look at the situation that we have here. It says the elevation of an object tells you its distance above or below sea level. So I want you to underline that, and I want you to think about that because a lot of students don't understand what elevation is. That just says how far above or below sea level it is. The elevation in Denver is really high, so it's harder to breathe there. I know this because every time I watch a football game, the Denver Broncos always seem much better equipped and conditioned for home games because they're used to having the thinner air. Their elevation is higher. In the Colorado Rockies hit the ball farther and out of the ballpark because the air is lighter and they're higher above sea level. Makes the ball go farther when they're swinging at baseballs. So elevation is something that does come into play in real world situations, but in this case, elevation is just talking about how far above or below sea level something is. Okay. Negative numbers are used to represent objects below sea level. So there's sea level, and then anything below sea level will be represented with a negative. Anything above sea level will be represented with positive. Positive numbers are used to represent objects above sea level. The table below shows the elevations of 4 objects. Graph their locations on a number line. Describe the distances of the objects above or below sea level. So we're going to describe their distance above or below sea level, and when we do that, we're going to represent them with positive or negative numbers. Okay. So what we have here is a mountain, and we're talking about kilometers. So we're talking about a significant amount of space in between sea level and where the mountain peak stops. 2 kilometers above. The fish are 1 kilometer below. That would make sense. Fish swim in the ocean. They're below sea level. The sunken ship, 4 kilometers below. That's way down low. And then the airplane, of course, 4 kilometers above sea level. So you can see that each of these is represented by the appropriate positive or negative number representing above sea level or below sea level. It says to use a number line. Graph their locations on a number line. And so this number line on the side, here's what I've drawn. And it's a vertical number line. We call this a vertical. I think of this as a Y number line because Y-axis is the vertical axis. And you can see that sea level is here at 0. Okay. Above sea level represents positive numbers, kind of like a thermometer. The higher the thermometer goes, the more positive it is. The lower it goes, the more negative that it is. So 0 is at sea level, and then we have 1, 2, 3, 4, and we have -1, -2, -3, -4. We've talked about opposites before in the past. The opposite of 2 would be -2, opposite of 1 would be -1, and so on. And opposites are the same distance from 0. So it says that sea level is marked and labeled on the number line. Mark and label the elevation of the objects listed in the table above on the number line. So if this is sea level, I'm going to look at my first object, the mountain. I would say that 2 is the mountain. So I'm going to label that at 2. That's the mountain. Okay. The fish are at -1. So if this is sea level, 1 below sea level would be there. That would be the fish, or the fishers, blub blub. There you go, little fish. Okay. And then we had the sunken ship way down low, 1, 2, 3, 4 kilometers below sunken ship. And then we have the airplane, the other direction, 4 kilometers. 1, 2, 3, 4, airplane. All right, and so that's where each of those places, each of those will be represented according to its relationship from sea level. It says how far above sea level is the mountain. Well, it's 4 above sea level. Oh, sorry, 2. Sorry, Mr. Gill misread that. 2 above sea level. How far below sea level is the school of fish? Now, I tried to make this a point on your last example video, I believe it was, about how distance is not a negative distance. Even if I drive my car in reverse, I'm still going space. There's still space there. And so we never represent distance as a negative number. So it says how far below sea level is a school of fish. A lot of you are going to be tempted to put -1, but it's not actually -1. It's actually just 1. There's still a distance here. This is still a distance of 1, just like this is a distance of 1, just like this is a distance of 1. Okay, it's still a distance of 1. How far above or below sea level is the airplane? Again, it's above, and we would say that it's 4 above. Or if the sunken ship, we would say it's 4 below. We wouldn't say it's -4 below. That would be a double negative. That would be like saying I ain't got none teeth. That means you do have teeth. I mean, it's a double negative. What two objects are the same distance from sea level? Explain how you know. Well, of these four objects, there are two objects that have the same distance from zero. That would be the airplane is 4 away from zero, and the sunken ship is 4 away from zero. We call those numbers opposites, which is something that we've been talking about. Even though they're opposites, they're still the same distance away from sea level. They're just in different directions. So the airplane and the sunken ship are both 4 kilometers from zero, and that's all it says on there. It doesn't really explain, but they're opposites. Might be good to put that word in there. It says, explain how you could find the distances from the objects from sea level. Well, you can just count from zero, or it looks like the book says you can count how far above or below zero the number is. So, of course, if it's labeled with a 4, whether it's positive or negative, then we know it is 4 away from zero. If it's labeled with a 2, it is 2 away from zero. If it's labeled with a 1, positive or negative, its distance itself is 1 away from zero. And so when I'm doing mental math problems, a lot of times, especially with integers, positive and negative, if I'm adding integers together, I think about their relationship to zero, so I can figure out how far apart they are. For instance, if I asked you, how far is it from -2 to 4? What distance is in between those numbers? Well, I know that -2 would take me 2 to get to 0, and then 4 is 4 more away from 0, so 2 plus 4 would be 6. I know that between -2 and 4, there's a distance of 6 between those, 6 units. So that's how I always compare the numbers when I'm thinking about distance. I think about their relationship to 0. And so when we talk about how far an object is from 0 or from sea level, what we're trying to do is actually find the absolute value. Okay. Sometimes this is also called the magnitude. I'm going to have you write this down on the side of your paper as well, the magnitude. And it just means how far away it is. Okay, so a lot of students make mistakes on this because it's a confusing concept. You need to know this definition really well. It's how far away from 0 that a number is. Okay, it is signified by 2 bars, straight up and down. The bars are usually taller than the number, and those bars mean the absolute value of. So I would read this part right here, the absolute value of -4. So the first thing you need to think of is, what does absolute value mean? Okay, that means the distance from 4. The second thing you need to think is, well, how far is it from -4 to 0? And I know that is a distance of 4 from 0. Absolute value bars are a type of grouping symbol. This is a grouping symbol. So when you talk about PEMDAS or however you learned order of operations, this would take priority over add, subtract, multiply, divide, or exponents. Anything inside the absolute value, that is considered a grouping symbol. It's a distance from 0. I can't emphasize that enough. So there are 2 absolute values that are 4 away from 0. The absolute value of 4 or the absolute value of -4. 4 is 1, 2, 3, 4 away from 0. -4 is 4 away from 0. Please do not think that this just means that you do the opposite. You can see that this was a positive and distance. This number represents a distance. It is how far away from 0 that the number is. Just because we're finding the absolute value of 4 does not mean that its distance is -4. That makes no sense at all. Okay? There's no space that is negative. All right. So the absolute value of a number is how far away from 0 it is. I said that like 1,700 million times, but it's so important and it's so confusing, and it's one of those things that like students just really have a hard time with because they try to take shortcuts. Like, oh, I see that this absolute value is of -4, so it must be +4. Then they think the same thing about positive numbers. Then they think it's supposed to be -4. Well, it's not. It's not supposed to be -4. Okay, so don't write that on your paper. You could write this on your paper. That does not equal -4. The absolute value of 4 does not equal -4. There's no such thing, negative distances. There's no such thing. We are not doing that in this class. All right. So that's how absolute value works. It's how far away from 0 it is. It's represented by these symbols here. It's very important. There are 2 vertical lines around a number or a phrase or a value. So if it said this, 4 plus 1, you would do what's inside of the absolute value first. 5, and I know that the absolute value of 5, its distance from 0 is 5. So I would go through a several step process to figure out what the absolute value of 4 plus 1 is. It would be 5. It would not be negative 5. It should be 5. 5 is a distance, and absolute value is a distance. Okay. So it says absolute value represents a distance, so its value is always greater than or equal to 0. The absolute value of 0 is 0, okay, because 0 is 0 away from 0. The farther a number is from 0, the greater the number's absolute value. So even if we had like negative 20, the absolute value of negative 20 would be 20 because it's 20 away from 0. In real-world situations, the absolute value of a number is often used to describe the situation. The elevation of the fish is negative 1, but it's you could say that the fish is also just 1 kilometer below sea level. Although it says negative 1, the negative indicates that it's down. Okay, its distance from sea level is still just 1 kilometer. The elevation of the sunken ship is negative 4 kilometers, but you could also say that it is 4 kilometers below sea level. Again, the reason we have negative signs is because we have two versions of the number 4. To know which side of the number line we're on, whether the positive or negative sign, we indicate if it's negative with a negative sign. So the distance is always positive. I cannot say that enough. Look at your number line on the previous page. What pair of numbers have the same absolute value, and how are the numbers related? So again, if this is my sunken ship, and this is my airplane, I know that they are the same. 1, 2, 3, 4. 1, 2, 3, 4. They are the same distance from sea level. Okay, and so the reason I know they're the same distance is because they're opposites. Okay, they have the same absolute value, or they are the same distance from 0, and they're opposites, meaning that they're 4 spaces from 0. So that's your introduction to absolute value. It's a distance. It's indicated by 2 vertical bars around whatever you would like to find the absolute value of. And that's it for today.